Hi, we're going to talk about, this is part 2 of our first set of YouTube videos. This one is on antiderivatives. Well, if I take the derivative of something, let's see, what is it, we'll say df dt, and it's going to be basically, we're going to basically find it of any function where f is x to the n, it's going to be n x to the n minus 1. And that makes sense. Antiderivative. The antiderivative of a function is exactly the opposite. Is the opposite. So the antiderivative of x to the n would be x to the n plus 1. But remember last time we would bring down a number, so we have to actually divide by that number, n plus 1. So that if we took the derivative of this, we would end up with just x to the n. That's our goal. So that's what the antiderivative would look like for that. So let's try a few more. The antiderivative of 3x cubed would equal x to the 4th, and the 3 would stay there because you would take the derivative of it, divided by n plus 1, 4. So it would be 3/4 x to the 4th. That's pretty simple. Let's try another one just to get a feel for that. If I take the antiderivative of let's see, with respect to t, let's say, of the acceleration, it's going to be a times t. Because since this is just a constant, the antiderivative is just going to give me the variable instead of taking it away. That's all it's going to do. And if I took the antiderivative of this, of a times t, again with respect to t, to time, it would be, the a would stay by itself, but I would take the antiderivative of just the t, which would be raised to 1 power, raised to 1 power divided by that power. So it would be a t squared over 2. And that's an antiderivative. Yes.